Good morning, Year 12. I'm putting this together shortly after the news broke that you're not going to be in school next week. I'm very sad about that. You probably have mixed feelings, but we're going to carry on. And please be clear that this material we do now, I am not going to recap at the start of next term in September. This is very much part of our second year course, and everything that we do now gives us more time for revision at the end of next year. So please engage in this. I intend to carry on with pre-recorded videos, but I'm very happy to do a live one-to-one session for anyone who is struggling. So please keep in touch. All right. So you've got Thursday. I gave you a task to submit. Thank you to those that have done that. Please make sure you do that. And there'll be a task to submit at the end of today's lesson, just a short one, and I'm going to continue that pattern through next week. So so today, before I explain what we're doing today, let me just sort of cover a bit of terminology. This here we call a function, and we display it on a graph. But at the end of the day, what's happening is what we used to do at primary school. We're taking a value x and we're doing something to it. This function is squaring. So we are squaring the x value to get the y value. So squaring is a function that we can apply in maths. And we've got a whole range of functions, haven't we? So I can square root. Square rooting is another function. And sometimes we do more than one function. So here we're squaring and dividing by 3. So we would have two boxes in our function machine. So what I'm going to introduce you to today is the modulus function. So the modulus function takes a value, and we indicate it with these bars either side. It returns the non-negative numerical value. So if this is the modulus function here, and I put a 2 in, a 2 comes out. But if I put a -3 in, a 3 comes out, because I am returning the non-negative numerical value, sometimes referred to as the absolute value, abbreviated ABS, which that's how the calculator implements this. Now, this notation we've met before because we've used it for the magnitude of vectors, and it's sort of saying it's the same. With a vector, we're saying I'm ignoring the direction, I just want to know how long this vector is. And now we're saying I'm ignoring the sign, I just want to know how big this number is. So the modulus function indicated by these bars just means what's the non-negative numerical value of something. So for example, if I have a function, and sorry, we're used to two ways of writing it, y equals or f of x equals, that's the way we write it. So here's a function involving the modulus function as part of it. So can you tell me what, just need to move down a bit, there we go. Can you tell me what would happen if I make x equal 5 in that function, if I make x equal -2 in that function, and if I make x equal 1 in that function? Pause and have a go. Okay, so if x is 5, 2 lots of 5 is 10, take away 3 is 7, and the absolute value, the modulus of 7 is 7. It's already non-negative, so 7 plus 1 is 8. If x is -2, then this becomes -4. Take away another 3, it's -7. And the modulus of -7, the absolute value, is 7. So 7 plus 1, we get 8 again. If x is 1, that's -2. Sorry, that's 2. Take away 3 is -1, and the modulus of -1 is +1. So that becomes +1, add another 1, and we get 2. So this is the modulus function, and we would never get a question like that. We are asked to do two things with modulus functions. One is sketch graphs involving the modulus function, and the other is to solve equations. So let's look at the sketching of graphs firstly. So here's a graph that I am being asked to sketch. It's a modulus function graph. And to start with, I've actually just sketched 3x minus 2. So I've pretended the modulus thing isn't there. So this is the graph of y equals 3x minus 2. I know it goes through minus 2 on the y-axis, and it has a gradient of 3. I could work out where it crosses the x-axis. I know that that point there is what I get when y equals 0. So if I say, right, when does y equal 0, I get... Right, so I know it goes through 2/3 on the x-axis. Now, the modulus of this, so we're saying the y value is the modulus of this. So while y is positive, then that's all very good. So the when y is positive, the modulus graph looks exactly the same. But as soon as y becomes negative, well, the modulus function kicks in and returns the positive equivalent. So what happens is when this graph drops below the axis, the modulus graph bounces and will come up above the axis, and this is symmetrical, so this is going to go through +2. So the graph of this function is my red V sign. So this line below the axis is not correct. That's the graph of the 3x minus 2, y equals 3x minus 2. The modulus graph looks like this. It is symmetrical, this bit, and this bit is the bounced section of that graph. And if we think about this now as two separate functions, really, until we get down to here, this graph is just the normal y equals 3x minus 2 graph. But for this section of the graph, it's not y equals 3x minus 2, is it? It's the bounced version of that, and to reflect a graph in the x-axis, you multiply it by -1. So this branch can be thought of as minus 3x minus 2, or minus 3x plus 2. So the graph of the modulus of 3x minus 2 is actually made up of two legs. One leg, which is the original function, which is there until it hits the x-axis, and then the bounced section, which is minus the original function, which we could either write like that or like that. Okay? So go on, sketch me the graph of that. Of course, another go at that one. Okay, so here we go. This is the graph of y equals 2x plus 1. So the pencil line that I originally drew was that. It goes through 1 on the y-axis, gradient of 2. Where does it cross the x-axis? Well, that's what you get when y is 0. So I ask, when does that equal 0? So that gives me minus a half. So that point is minus a half. And there we go. And in terms of the equation of the two separate legs, well, the original leg is just the function without the modulus sign. And then the bounced leg is minus that. So that's minus 2x minus 1. And the reason why I'm thinking about it as two separate functions crops up in a minute. So okay, see if you can sketch me a couple of other functions. Let's have the modulus of x squared minus 4 and the modulus of sine x, and for that perhaps we'll go between 0 and 360 degrees. Okay, so see if you can sketch me those two modulus graphs, and then we'll have a look at how the calculator does them. Okay, so I've sketched x squared minus 4, so the modulus of x squared minus 4, unchanged there, but this bit here bounces, so it will be like that. These 2 points here, well, they're where the function equals 0, and hopefully you were able to see that was plus or minus 2. You could either factorise it or just solve it as a normal equation. So that's minus 2 and that's plus 2. And then we've got, this is y equals x squared minus 4, this bit and this bit. And this bit is that reflected, so that's y equals minus x squared plus 4. Or you could write it as just minus outside a bracket with x squared minus 4 inside the bracket. So that's the modulus graph. And then this graph here looks all happy and normal there, and then bounces there. So this is sine x and that's minus sine x. So that's modulus graphs. Let's have a quick look at how we do those on the calculator. Okay, so let's look at how we can sketch these graphs on a calculator. We've done 3 so far. Well, we've done 4, but I'm going to do 3 here. Actually, no, I'm just going to do these 2 actually. But yeah, let's go for it. So menu, graph, and to get the modulus symbol, you need to, and it's never straightforward, is it? Go to option and numeric. And there it is, absolute. They call it absolute, not modulus. Press that button and you get your 2 little bars. So if we do 3x minus 2, and draw it, there we go. Now interestingly, and I haven't really got an answer for this, gsolve won't tell you the root. It says it can't find one. There is a root, and we've calculated where it is. We know it's at 2/3, but yeah, it does work for some functions, it doesn't work for others. I have no idea why. Anyway, let's go back to and delete that. And so I want to go to option, numeric, absolute, and let's do x squared minus 4. There it is. And I think gsolve works for this one. Yeah, so we know it crosses at minus 2 and plus 2. So there we go. I'm sorry, I have no idea why gsolve isn't working. But anyway, that's how you do modulus functions on the calculator. Yeah, it's pretty straightforward, isn't it? Okay, so let's look at solving modulus equations. All right, I'm going to do 3 examples. And there are a number of ways of approaching these equations. And you know, different teachers argue about which is best. But I'm delighted that the textbook we use agrees with me, and I always solve these graphically. To start with, it's a bit slow, but before long it becomes super quick. So I'm going to solve this, rather than using algebra, I'm going to solve this by sketching y equals that and y equals that, and asking where do the lines intersect. Okay, I'm not going to do an accurate sketch, so I'm actually going to use a bit of algebra along the way, but I am going to do a sketch to help me see where I need to be looking. So go on, see if you can sketch y equals that. So that's just like we've been doing with these ones, okay? And then y equals 5. I hope you know what the y equals 5 line looks like. And then I'll come back and we'll have a look at how we use that to solve that equation. Okay, so here's my modulus of 2x minus 1 graph. Bounces when it hits the x-axis. Goes through 1 instead of minus 1. I could work out this point here. I don't actually need to in this case. Here's my y equals 5 line. So I've got 2 solutions. There are 2 places where these 2 lines intersect. So there are going to be 2 solutions to this equation. This equation doesn't mention y, so there's not going to be pairs of x, y values. There's just going to be 2 x values, but I'm using graphics, a graph to help me find those. So this comes back to what these 2 legs of the graph actually have as their equations. This leg here is the y equals 2x minus 1 graph, isn't it? This bounced leg is part of the y equals minus 2x plus 1 graph. It's minus that whole function multiplied by minus 1. So this intersection here, I'll call it intersection A. A is where this graph equals 5. And this intersection here, B, is where this graph equals 5. So I can work out my 2 solutions. And here and that seems to make sense. This seems to be roughly roughly 3, and this seems to be roughly -2. No y values, all right? I mean, the y values are both 5, but I'm not after coordinates because my original equation is just in terms of x. Now, some of you will be looking at this and thinking, well, hang on a minute, isn't that really easy? Do I really need the graph? It gets more complicated, and I think getting into the habit of drawing the graphs is a really, really good habit to get into. Let's just pause at this point and see if we can sketch and solve the same problem using our calculator. So I've sketched y equals the modulus of 2x minus 1 and y equals 5. Just 5, not modulus of 5, just 5. I mean, actually, it wouldn't make any difference. And so I get that, which is the same as I got here. And then g-solve and intersect. So yeah, x is -2 is one solution, and x is 3 is the other solution. Now, we're in the realm here of things that we are expected to show manually, but there's nothing to stop you checking that using a calculator. Okay, let's have a look at the second sort of problem. Okay, so another problem here. Again, I'm going to solve it by sketching y equals that and y equals that. And in terms of y equals that, I'm going to firstly remember that that's actually the same as that. So, and it's not modulus. So go on, have a go at sketching both of those, and then we'll come back and see where they intersect. Okay, so there's my modulus. This is y equals 3x minus 5, the original function, and this is y equals minus 3x plus 5. This line here is that one. Just checking I got this right. I mean, it's fairly obvious I got it right, but where does this graph cross the axis? That's when y equals 0. So minus a half x is -2. So double both sides and divide by 1. So that's 4. And this graph, when does that equal 0? 3x minus 5 equals 0. So 3x is, so it's 530. Yeah, so I've got those sort of points the right way round. Okay, so I've got my two solutions here. Solution A, solution B. So solution A is when the original function hits the minus a half x plus 2 line. And solution B is where the bounced bit, which is minus 3x plus 5, that's where that hits the original, that one. So I can solve those two, if you just want to have a go at solving those two, and then I'll come back with the answers and we'll check it on our calculator. Yep, sorry, that was 2, not 5, wasn't it? Made a mistake there. Apologise for that. Anyway, so I get x is 2. I doubled everything to start with, make it easier for myself, and 1.2 here. And I checked that on the calculator, and yep, I get a solution here of 2 and 1.2. So yeah, that was confirmed. Again, some of you will be saying, well, isn't it just this equals that and minus that equals that? In these simple cases, yes, it is, but we're trying to get into good habits with the graph. Okay, let's look at the third sort of problems. So we've got inequalities here. So go and start by sketching y equals that and y equals that, and we'll see if we can then use that to, and I tell you what, and go on and find the intersections. Yeah, let's do that bit, and then we'll talk about what the difference the inequality sign makes rather than having an equal sign there. So see if you can get to the point where you've sketched the graph and found the intersections. So I've got my two intersections here at 1/8 and a half. And you know, I know the graph's right because 5x is always going to be steeper than 3x. So the red line, the way I've done it, is less steep than the white line. If I sketch that on the black line, sorry, if I sketch that on my calculator, a bit vague, but of course I can use the plus sign to zoom in and the cursor to sort of investigate it. Because remember, G-solve only works if you can see it on the screen. So So there you go, that's a bit clearer now, isn't it? So if I now g-solve that and work out those intersections, yeah, so 0.125 is an eighth, and 0.5, that's a half. So I'm okay, I've got my two intersections. Now, we've got an inequality here. Now I did this line in black, and I did the 3x line in red. So what we're asking is, when is black above red? So on my diagram here, when is the black line above the red line? Well, it's above the red line before you get to A. So it's when x is less than 1/8, not equal to, because I've got no equal to there. The black line is also above the red line after this point, so when x is greater than a half. And I think this is where the graph tends to help us out, because without the graph, if you just worked out the 2 points, you wouldn't really know whether it's a greater than or above, you know, the sandwich or the tails, as I've said in the past. And also, you need to be able to sketch the graphs. That's part of what's expected of you. Sometimes you get just sketching questions, so it's, you know, it's killing two birds with one stone. Right, high time you did a little bit of practice for yourself. So on page 26 in the Year 2 textbook, 7 and 8, and those are two without inequalities. Then page 27, question 12 is one with inequalities. And then page 27, question 10 is one of those spot the mistake questions. And in this question, a naughty student has tried to skip the graph and has gone straight to this point here, and it's led to an incorrect answer. So I'd be interested to see how you get on with that in terms of spotting what the mistake is. And to spot the mistake, you've got to try and sketch the graph, and you've got the option of using a calculator for that. So there we go. Have a go at those, and then if you could submit your answer to the inequality one. So that's page 27, question 12. So I'll just put a copy of that on OneNote, and yeah, we'll get into that sort of routine for the next week. Good stuff. Please keep in touch. All right, as I say, we're doing pre-recorded lessons, but if you really want some one-to-one support, very happy to do that via video link. Take care.